Hi, welcome back. We have interested panel discussion on industrial applications on AI. For this, we have Malik Moturi, who is the Vice President of Product and Business Development at Scientend Corp. He has more than 25 years of semiconductor industry experience, creating innovations in technologies such as neural networks, DSPs, multimedia, networking, SOCs, and FPGAs. Mr. Malik Moturi has held technical and executive leadership roles at various very warm welcome, Mr. Malik. So nice to have you for this panel discussion today. Now we have another panelist, Manish Kotari, serves as Vice President of Silicon Labs, India, a leading power of silicon software and solutions for a smarter, more connected world. He serves as a site lead and he is responsible for growing the wireless engineering talent, build scalable infrastructure and foster local partnerships in India. Hyderabad being the company's newest and fastest growing wireless development center. He has more than 20 years of experience in technology management, most recently serving as head of wireless systems and software product development at Qualcomm, Hyderabad, spanning cellular from 2G to 5G. He has built and managed teams of more than 1,000 wireless developers and system engineers and holds more than 100 patents. Manish graduated from the IIT Madras and received his MS and PhD from Massachusetts Institute of Technology. So nice to have you, Manish ji. And we have Shan, a holiday brings 20 years of experience to his role leading customer success for Blaze. Shan's extensive background in marketing, strategy, business development, and technical experience underlie his successful track record delivering notable results in startup and Fortune 500 company environments. He has managed trailblazing products from idea creation, market analysis, concept approval to development, launch, volume production, and market adoption. His leadership and team management skills span multiple disciplines, multiple cultures, and geographies. Prior to Blaze, Shan was a senior director, business development at Skipco, where he held new market and new business development for an innovative broadband communication silicon startup. He was a former director, new business development and market development at Intel. Over his 16 years career at Intel, Shan has leader in identifying, developing, and launching new technology and business opportunities in the area of next generation broadband IoT customer platforms and wearable technologies, for which he received several Intel Division and Program Recognition Awards for excellence in development, product marketing, innovation, and business development. Shan holds a bachelor degree of science in industrial applications from California State University and Master of Business Administration from Golden State University, San Francisco. So Shan is the founder of Cycles for Hope, a 501c3 organization that has provided thousands of recycled bicycles and services to the people in need from California to Africa since 2008. Warm welcome, Mr. Shan. We are very blessed to have you here. And we have another young entrepreneur who started his journey with semiconductor sector at the age of 18 years, Gangadhar Gude, founder of @AI Labs. He founded @AI in 2018, an applied AI company that deals with edge devices. He holds a bachelor's in electronics engineering from Osmania University and an MS in VLSI from JNTU. Before founding @AI, he worked as methodology architect with AMD Incorporation and then co-founded Envicus, where he was honed his skills in building end-to-end products With a career span more than a decade, Gangadhar strongly believes that passion coupled with purpose is the pathway to progress. With this motto and vision, he founded ATI, which provides applied AI solutions to supply chain, logistics, and business oriented requirements with an aim to integrate technology for a greater enhancement of products and services. So nice to have you, Mr. Gangadhar, here. And now Gangadhar will chair this panel discussion.
Thank you, Satish. Good morning, everyone. So just to start off the day, I think let me give you a brief abstract or a brief understanding on what we would like to talk about in this panel today. Artificial intelligence is making strong inroads in all frontiers of businesses, started predominantly in new age businesses, such as social media, IT infrastructure, e-commerce, ride-hailing companies, and etc. And predominantly, it's been driven towards autonomous vehicles. But if you look at most of the traditional industries, such as manufacturing or food processing, agricultural, supply chain and logistics sectors are still very nascent in very nascent stages in adopting AI. So the biggest thought process is AI adoption to these industries should add multiples of trillions of dollars to the global economy, and also give you a lot of intangible benefits, such as reducing the food shortage, reducing pollution, and improving overall the quality of life. Today in this panel, we would like to discuss the industrial applications of AI in these traditional industries, and what are the challenges in adopting, and what is the way forward for fastening these deployments. To give my view and perspective on this, there are many industries. We're talking about healthcare, we're talking about autonomous driving. Today, if you order anything, take like the Swiggy, we're talking about Uber Eats, Uber, Lyft. There's so many applications, softwares, what we're applying in industries that have popped up with this new AI, which is pretty much making the ease of living or ease of moving forward in life much better. But if you look at the traditional industries like agriculture or supply chain, today supply chain stands like, you name it healthcare, you name it food, you name anything. How do we move objects from one place to another? It's still like 20 to 30 decades behind in technology standpoint of view. In the last few months, since COVID has hit, these industries are now trying to figure out how can we improve the yield, how can we improve the efficiency, how can you improve the time. For example, if you take crop or food, perishable food, today in a global economy, the amount of food produced, almost 60% gets wasted because it does not reach in time to the end consumer. And that's a huge, huge volume for us. These perishable goods, pretty much, if you don't bring in the expiry time, they're all gone to waste. 60% is heavy. And take, for example, if you go on this agricultural, take certain product is supposed to be made in a certain time of year for certain weather conditions. And if by any chance something goes wrong, the whole yield goes to waste. So how does AI come into this picture? How are we as an industry adapting AI or these new devices or these new analysis to increase the productivity and use this technology to go forward? And the other question is the technology mature enough to support these type of industries? What are the sensors available? What is the network or the compute available? Is there enough? And is there any push coming forward from the industries? The last but not least thought process from my side, which I would like to talk about, is how much is the government supporting to improve or accelerate this adoption in overall these industries? Because from an India standpoint of view, this is very much needed for us to grow, because we are predominantly a country backed by these traditional industries. Sean?
Yeah, thank you, Genda. So I share many of the things that you just mentioned. And one of the really cool things I get to do here at Blaze is engage with customers around the globe. And I've personally seen the application of AI in real world applications in different markets and different verticals and different segments, as you've mentioned. And I too believe AI is going to change how we do business around the globe, not only in terms of economics in making our businesses more efficient, reducing OpEx, but improving the human experience. As you mentioned, food production is a huge challenge around the globe. How do we keep from wasting food? How do we increase our yields in such a way that we can get food to where it needs to be at the right time, at place, and logistics? AI for education, for example, we've seen this during COVID. It's changing the way people learn, how we're going to learn what we need to learn about. So it's going to impact that. Climate change. I mean, one of the hottest topics that are across all of our nations and around the globe of how are we going to handle this? And AI is going to play a huge part of that in analyzing what's going on and how we can respond to it, how we can adapt our businesses, how we can adapt what we do personally to impact that. So I'm really excited to be part of this because, like you said as well, AI is just at its infancy, and us as technologists, everyone who's participating in this summit, we are the group of people who are going to help make AI usable by people around the globe, whether it be in agriculture, or in the farms, in the schools, or in traditional industries, as you mentioned. It's going to be up to us to help them adopt this technology, put it to use, and address some of these big challenges and problems. So I'm excited to be part of it. I'm excited to talk about it here with the fellow panelists, and hopefully we can come up with some good solutions and recommendations that'll make sense for everybody. Thank you.
Thank you, Sean. Malik?
Yeah, hi. Thanks, and I really appreciate the opportunity here to speak at the IESA. Thank you for setting it up. It was great. So I wanted to I was listening earlier to Wally Ryan speaking about, at the very eminent speaker, and really I want to riff a little bit on what he said. I mean, 3 points I think which I kind of caught, and I thought it's also relevant to what we are talking about here. One is he mentioned was the Internet of Things, right? He said IoT, but said other one was really the security of the content, how do you keep it secure? The third one was data being the new oil, and how a lot of data is. So let me kind of riff on that, right? So if we, at least we've been talking about it internally at Sentient, and we are a AI chip company, but we look at it as the IoT. I call it the new IoT, or the intelligence of things, right? So industrial IoT, or industrial devices, or IIoT is one of the terms that is thrown around, right? So we are seeing a lot of renaissance in technologies entering into all kinds of devices around us, right? Devices, machines, how to use automobiles, you mentioned. These things that we use in our daily life, home, office, factories, and outside, smart cities, what we are seeing. These are all becoming much more intelligent. It's simplifying and enriching our user experience. You see it every day on your smartphone, all the things that it can do. That's just just one example of our day-to-day, how intelligent devices are becoming intuitive, perceptive, even take reasonable autonomous actions, right, based on situational awareness. Now, these things are enabled by technologies like what some of the things that we are building and our other semiconductor companies are building, that allow these things to happen at very low power and ability to make it ubiquitous AI, right? So that's the revolution this revolution is happening in that industrial, that IoT, or intelligent of things space. But the other thing is, it also solves certain problems, right? Which are effectively those in the earlier days. Today users of devices or these IoT devices use, those problems. You come across a supply chain issue, right? Let somebody solve it, right? You put a bunch of people on the problem, and then they go figure it out and solve it. Or they use some conventional algorithms to say, supply chain management. But if you apply AI to those industries, to understand the problems, being able to predict based on the data that they are getting from everywhere, that is where I think this trend is accelerating now. This is where I want to talk about data. There's vast amounts of data being generated, but stored, goes into the cloud, goes somewhere, and there's no ability to kind of mine the data. And there's, we're trying to do that, right? But those efficient algorithms need to be there to mine this data. There's a flywheel of this vast amounts of data coming in. Specialized silicon is coming together, as you know, like otherwise you'll have to build these large data centers and we are doing that today with consuming vast amounts of energy to do certain amount of processing of analysis in the cloud. So I think on-device AI, edge AI, combined with all the sensors we were talking about earlier, right, enables this privacy of data or protection of the data, reliability. That means it doesn't, there's no connectivity or whatever. The data is still analyzed and available right there. And responsiveness. If you want all of these machines or devices out there, and energy efficiency is very important in this new intelligence of things across all industries. Now, industries, I mean, it's a global economic output, right? From all this, what is it, like $5 trillion of manufacturing, the overall industrial output, from manufacturing to transport, or you name it, right? Utilities or other those kind of big industries. Billions of dollars are generated. I'll talk about semiconductor industry as a whole. We generate $500 billion in revenue as a semiconductor industry today. AI contributes probably today 5 to 6 billion in the EBITDA, meaning the earnings of that industry for that industry. The potential, according to McKinsey report I was reading recently, was that it could be potentially 80 to 90 billion dollars. That is in the long term being 4+ years. In the midterm, in the next couple of years, that EBIT, earnings before taxes, it could be more like something like 30 to 40 billion dollars in growth. So those are huge numbers, but that's the scope of where we are seeing all of this happening. I don't want to get into, we'll talk more details later, but there's a lot of different industries I want to talk about. Like you mentioned automotive, then manufacturing. There's a lot of things we can do in manufacturing we are seeing today with AI. So I'm looking forward to continuing this talk and exploring all the various industrial applications as well.
That sounds great. Thank you, Malik.
Thanks.
Nish.
Thanks.
Hi. First of all, I'm really honored and humbled to be part of this conference, and thanks for having me here. And with this eminent panelist and the host that we have here, I think the journey of industrial applications, for AI, I think is just kind of on the trend line of how automation started, right? You went from manual kind of factories to automation, and AI is just another step in that direction. And I think when you look at what the place where Silicon Labs comes in is, we are kind of the leading leaders in IoT, and you can call it intelligence of things and Internet of Things, and we live in the what I call as end nodes, which are sensors. For example, think of your factories today, any industrial application, there are sensors galore, right? That's been part of your automation journey, whether it's for predictive maintenance, whether it's for security, whether it's for monitoring, whether it's for your efficiency and productivity and all of those things. So now the question really, which is why I feel we are really at the beginning of this journey, is is really kind of now trying to figure out what is the right architecture and what kinds of problems can be solved, at what I would call the end nodes, which if I may call as the micro node, micro edge, because I'm trying to make a distinction between edge and cloud. Micro edge is like sitting on the end node, right? And there are a variety of different things. If you take for example, to look at the requirements, if you're an end node like an autonomous robot or a car, you do have a requirement of a lot of the inference and the stuff to happen right at that node because of latency requirements, right? So there's nothing that can go to the cloud. You have to have good amount of stuff here. So we're in this domain where you have a micro edge and you have a thin edge, which is all your networking equipment. Then you have your, your thick edge, if I may call it, which is your data centers at your cell phone base stations or in-premise clouds, data centers, and then the actual cloud. So there is a whole layer of possibilities and solutions. And I think it's very interesting time because not every problem, there's a clear-cut solution to say, look, this needs to be done, at the end node. I think the analysis has to be done. Now, what goes into that? And I think we'll talk a little bit more about applications, but typically the things that, industrial applications or if I were a Bosch, for example, I worry about is privacy of my data, right? Because that's my core competency. I mean, the number one thing, just like for a human, data is the oil, it's same thing for industries, right? So it's very, very, for them, what goes to the cloud, they're super nervous about, right? So in the home world, where you have the Google and the Apple ecosystem, it's very hard to think about that on the industrial side. So that does slow down a pace of innovation a little bit because they want to keep a lot of that. So that drives a different architecture and solution. There is a power constraint, right? You want all these sensors and devices to be placed anywhere. Not everywhere you can rely on wired power. There's also bandwidth and latency and the cost associated with it. So there's a variety of different things that one has to worry about in a factory floor or in industrial applications to kind of look at what is the AI's methodology and the system architecture that I need to think about as I look at doing stuff for my application. So I think that's kind of the journey, and I think we're very early in these days, and I'm looking forward to having more specific discussions and examples and applications as we go forward.
No, thank you, Manish. So I think after listening to all of you, I have a question. I think I'll put it more in a general standpoint of view. I see all of you have a lot of experience with IoT. Sean, Manish, and Malik. Now, how far is this conversion of IoT to AI happening? Like, is IoT AI, or is it changing from IoT to AI? What is the difference? And how are these industries adapting to this?
Can I take that for a second? Ganadhar. So I think first step was, when I mentioned IoT and I said intelligence of things, what I was trying to talk about was, traditionally and today also we see these devices which are, even in the industry and factory floor and other where we see microcontrollers, their DS signal processors I'm talking about the semiconductor, at least the chips, right, side of things, where they're very small, they're low power, but still the capacity of the von Neumann architecture or Harvard architectures that they have, processor based or DSP based, they are still access memory and data, and they're very resource constrained today. So that is the challenge with that. What has happened is they're trying to kind of cross the chasm here and trying to figure out how to make it add intelligence to those devices, sort of adding AI, neural networks, deep neural networks into those devices, tiny devices. The challenge there is that it's going trying to retrofit it, with the new requirements. So we know how it works in the cloud. We know the massive amounts of data coming in. We know how to take all that and train it, and then, but this inference devices that we are putting in spreading it, because they have to be. I mean, I think Manish mentioned this. One of them is energy efficiency is very important, right? So you have to be very low power. You got to be able to sit in the factory floor or whatever and run for months together there's no probably a plug point or something that you can plug it into there, right? So those are, energy efficiency is important, and I think mention of data protection. So all of these things are, things that means that you have to be able to analyze the data at the node, at the edge, at the local, at the point where the data is generated, and that is really where intelligence is entering into the IoT.
Yeah, so I think if I could go next, and I think, just to add to what Malik said, right? So when you look at IoT, traditionally it's been about sense, control, compute, secure, communicate, right? It's just in that's really the essential of what IoT has been doing, whether it's in your home, as a light bulb. Now, what happens is, as you have that, the question now becomes for an end node is like, what can you infer, right? And and so the inference part of it, whether it's an event detection. So think about, I'll go into an application to give you an example. Like if you have a key part of a lot of factories and machine tools and others is about vibration being a very good source of kind of figuring out when the endpoint failure or a predictive maintenance schedule, right? You can infer that with a Cortex M processor, with tens of kilobytes of RAM, right? So there is a whole range of applications on the sensors which are not even one tops. They're like well below. You're running on a Cortex M sub-gigahertz processor. And Malik is, right. There are certain applications, which you just cannot fit in that, right? Now there is a whole host of stuff that's happening in the industry, right? There's tiny ML that's running on the processor. You have to figure out the energy efficiency of it. As Malik said, sometimes you may consume more power in computing than what you may save in communicating, right? So there is that whole system analysis of what's the right solution, but there is a bunch of applications where these sensor nodes, which I would call as the old IoT, if I may say that. The new IoTs, these sensor nodes are becoming intelligent. And the level of intelligence depends on the level of capability, and I would say a period in time. I think Wally clearly described, and I'm a firm believer that these intelligence nodes, the end nodes, would get powerful over time. Because if you just look at the process nodes they're working on today, they're in 110 nanometer, right? Moore's law hasn't caught up with them, right? So there's a whole journey that they're going to traverse where a lot of computing power and a lot of architectures and special purpose hardware, and that's already we're seeing now. So when you look at in time, if you just look at, it does make sense. I'm not saying for all of them. It does make sense for a good number of applications where it's important to have intelligence at the end node. And what level of intelligence you do depends on a variety of things. And I think, which we talked about, cost, security, right? It's a lot easier. Why do industries like inference at the node? Because what you transmit is purely let's say, a function, a convolution function of data, right? You're not sending the raw data out. So that's a huge, paradigm shift for them. They really like that. They really like the fact that what you transmit is some convoluted, kind of data, which is not your raw data. So there is a lot of that. It's also a function of time. Today, there's only a certain amount of things you could do, on your end node. As I mentioned, depending on your process node, the cost you can afford. But 5 years from now, I think if you want to project out, I do believe that intelligence will move down. That doesn't mean that cloud will go away or edge will go away. They will do different and better things, right? We'll be running 100 tops, right? We'll be trying to kind of capture brains. So, there's going to be an application. But what I think about today in the next 3 to 5 years, my crystal ball is we're living in this whole world where sub one top kind of applications, which is running on a gigahertz or low processor with tens of or hundreds of kilobytes of memory, not megabytes, are prime for innovation to address the kinds of problems we're talking about, which is cost, power, latency, right? Security. So these things, are going to happen and are happening, and we are seeing already products shipping out with our customers. And I talked about, predictive maintenance as one of the examples.
Yeah. I'll add to that, guys. And I think the really cool thing here is that the IoT has laid the infrastructure out for AI to be successful in these spaces. I've been around long enough, and I have the lack of hair to show it these days. Of before it was called IoT, it was machine to machine, or just the days of programmable ladder logic machines when we just ran information between. So, but the infrastructure is in place, right? And now we're seeing whether AI is going to be pushed all the way to the sensor, which I know we'll touch on that topic later, or it's being done in the cloud. We have an infrastructure. Bring in 5G and communications today. It even opens it up more. So we're hitting that perfect intersection of available infrastructure, the right size compute. You talked about tiny ML and small processing nodes running really tiny programs, but still doing inferencing to the big heavy lifting that's going to happen in the cloud and everything in between. And the way Blaze looks at this from a company is there's very distinct points and areas where the exact same workloads can be done, or the type of workloads or applications, maybe at different levels of processing, all the way from the sensor at the edge, or as was said earlier, maybe in the mist or the fog or the cloud. But my key point here is, and what makes me really excited is that the infrastructure is laid out. IoT has laid the road, the infrastructure for us. Now it's up to our industry to come in and provide the right technology, the right software environment, the right applications, and so forth, especially as we're talking about industrial. These are right, getting AI onto the agricultural equipment, which we're seeing move forward really quickly today. Getting AI out into the cities to help with logistics. The infrastructure is there. Cameras are on intersections. Let's start pushing AI out there. So it's ripe to move forward. And I think the next 4 to 5 years is going to be super exciting. And you'll see a hyper growth in the application of AI in traditional IoT areas.
I think, just to, my takeaway from all of you guys is something we learned, the 3 Ps: price, performance, and power. These 3 is what dictates what level of AI is going to be embedded and what level of IoT is going to be used, if I'm not mistaken. Just trying to sum up for this question. The other question, we've been getting some questions from the crowd already. Before we move on to the crowd questions, audience questions, I just wanted to ask one more. It's a sum of things. I mean, a lot of questions nowadays in India. What are the biggest challenges that are happening in industrial usage of AI? And they sum it up with, will AI replace human beings? Because that's the biggest question a lot of people are having, especially when it comes to these industries. And that's the reason there's been a lot of pushback. What is your take on this?
Yeah, I'll start off with that. First of all, I'll say no. I do not believe AI is going to replace humans. I think we've already seen, coming from the early days of the first industrial revolution to where we are today with factory automation, we've seen probably the vast majority of where maybe human labor has been replaced with automation, robotics, and so forth, right? And what has happened over the years? People who haven't lost jobs, they've transitioned their education, they've transitioned the type of work they do to utilize that machinery to augment, to complement their work. And I think we'll see the same thing with AI. AI is going to come in like in the agricultural space. Instead of workers having to go out to physically look at or take samples of the soil and the plants, that capability will be built into the agricultural equipment. We're talking to customers today that are adding AI into cameras that are taking high resolution pictures of leaves or the plants that are growing and determining, does it need insecticide or does it need fertilizer? What is the best thing to apply at the right ratios to get the best growth rate? That's not necessarily replacing humans. Humans may now be coming around to look at the data science behind that needs to be built into it. So it's augmenting the work that's going to be done. It's going to change the way we work. It's changing our education levels. And so it's funny. I just did a quick Google search of this before because I knew it was going to be a hot topic. And there's opinions all over the place. But overall, my personal opinion is the answer is no. AI is going to be hand in hand with humans working. Again, whether it's for agriculture industries, whether it's for really big problems like climate change and others, or pandemics like what we're doing with today. Let me give you a great example of AI working hand in hand. early in the pandemics, you saw a lot of, if you went on GitHub, you saw a lot of companies working on, how do we assist doctors? How do we give them technologies to quicker analyze and tell if somebody has COVID or not? And then what are the impacts of COVID? Obviously analyzing, doing blood tests, PCR tests were a big part of it, but they take a long time. So people started looking at how do we do visual imaging? Visual processing is a huge part of AI today. So our company, our data scientists put their heads together, worked with some industry colleagues, and very quickly came up with a way to analyze X-rays and train models off of public data sets. And then we even learned that X-rays in different geographies, people's anatomies are different, to train those to determine, does someone in the Philippines have COVID because it looks like different than somebody who has COVID in India. We were able to do that very quickly and put a tool in place with colleagues to have a go, no go in a matter of seconds by looking at an X-ray. Did that replace the doctor? No, but it allowed the doctor to diagnose, 10x, 20x, 30x more patients quickly to get them the care they need or take appropriate decisions within their municipalities and local authorities. So it's a great example how AI will augment what humans are doing today and not necessarily replace. So I'll hand it over to my colleagues to comment.
Yes, I mean, I think I could, look, it's a very, very, tough question. And I would say there's a lot of more eminent personalities and thinkers greater than, at least for me, like Elon Musk and others who have a lot of opinion on it. But I think I'm kind of with what Sean outlined, right? Like what I see is, if you just back up at like 10,000 foot, AI replacing humans requires you to develop some level of general intelligence, right? Which is kind of what our brain does. We're very, very, that's like very far out, right? We only understand like 1% of how brain works today. So there is that element of it. The more important thing, I think, that is more relevant is kind of what Sean talked about, is there will be people who will be impacted, just like when automation occurred, labor was impacted, but reskilling, retooling, rethinking about education also becomes very important. I think going to what Sean talked about is how machine learning is really changing medicine, science, medicines. I wonder if you go to a medical school in 10 years from now, would you need to know machine learning? Because a lot of the diagnostics and the stuff that's being done could be automated. That doesn't mean the doctors are not required, but they will be doing different things. What are those? And I think those are the things that I think are more relevant for all of us as a society to think, is AI would require us to retool, reskill, rethink how education, every aspect of things are done. So I think that's where I think it's very fascinating. But my fundamental belief is, it's just the human brain is. I think just if you look at where we are in terms of understanding of general intelligence and kind of just having a machine that just thinks as computers and machines taking over humans, as really kind of replacing humans. I think that I'm not qualified to talk about it, but just being an optimist, I think we are far away from that, and that's unlikely. But more realistically, there will be an impact to people, and I think we as a society have to really do our job to reskill and retool people, and really look at how we are training people and how we are skilling. And I think whether it's engineer or a doctor, what you learn 10 years from now, it's very important that what you learn, because certain things may not be required or may be done better by a machine, right? But that doesn't mean a human is not required, right? You just you have to upskill and you have to do something different, because it frees you to do other things, right? Bigger and better things. So I think that's my humble view, if I may.
I will give you a couple of examples. Thanks, Manish. I think I think the point I think you had mentioned was that you have to relearn a few things, but just give me a couple of examples so we kind of go to the point of where things are changing. Just basic thing like we've been working with companies in the retail industry to do speech recognition. Right, so we are one of the Sentience core technologies in speech and voice and audio. And speech recognition would allow you to go to a fast food or any one of those retail location point of sale and ask for whatever you want, and it can be delivered to you without having without having to go to having a human to do that order taking, for example. Right? That's one example where it's changing already. We're seeing that. We have one of my colleagues, friends, works at he's heads the AI division of McDonald's, and they are setting up these speech recognition, complete ASR stations where you can just go place your order without having a human to take the order for you. That's an example. The other one, I was just coming to the semiconductor industry. Physical design has been traditionally done by humans, right? I mean, you put a lot of resources spend on months and months of doing physical design. More and more, we are seeing that actually being done by AI engines built into the EDA tools that they can do. It's come to a point. It's really very, very hard for a human. You still use tools. We still use tools in the past, but they are now going right from design to GDS without having to have a human to do the physical layer anymore. So those examples of right from order taking to physical design, or really a hard like silicon design, changing industries, changing where humans are not needed anymore.
I think, thank you, Malik. I think just to sum it up, in the standpoint of view, yesterday there was a speaker also that Mr. Jayesh Ranjan, who is our IT secretary of our state, was telling us there's a university in Telangana that is enforcing AI as one of the courses that every student has to take. So it's not just engineering, or it has to be architecture, arts, you name it. Everyone has to do one coursework of AI, because how do we apply this for our application to improve ourselves? And that was a key goal. I mean, that's the new changes that are coming about, even in education, like you stated, Manish. I think that's one of the steps that are being taken. I think we have time for one audience question. I just wanted to. So, how do we see AI in embedded systems, or is it still only at research stage?
It's not. It's far from research. We are shipping 10 million products. We already shipped 10 millions of chips going out. Deeply embedded AI chips in the market today. We have many different products that we are shipping into, and these are full neural network sentient core. Are all neural processors.
Yeah, and I think if I were to add to what Malik said, right, like my former eminent employer Qualcomm, Snapdragons have smartphones today have it's an embedded system, and it's got tremendous amount of neural network and machine learning capability, and famous use case being face detection, right, image recognition. So I think we are quite far in that journey of intelligence in embedded systems.
Sean, you're on mute.
Sorry, yeah, everyone. No, I sure hope we are. Otherwise, I'm in the wrong business. It's embedded's been around for a while, and tying back into IoT. AI, and especially the type of processing, and the previous speaker before our panel had mentioned the change in compute that's going to happening. So one thing I'll say is, yes, AI is out in traditional embedded devices today. We are seeing it in mobile devices. The fact that I can't go to a McDonald's and verbally order my French fries today is a true testament to that, right? We're seeing it in the retail centers. When you go to a shopping mall today and you walk in, cameras, and everything is running on AI. These are all truly embedded systems running on traditional real-time operating environments and so forth. So I see that it's fully there, but I think there's a lot of room to grow, and that room to grow is in the type of processing, the type of programmability that's going to be required. AI is very much in its infancy in terms of being applied in the industry. We're still learning. Models are changing daily, the types of models, the size of models, data sets, technologies for labeling data. is changing on a daily basis. So what I expect is that we're going to see a change in the type of compute required as AI grows, and that's going to be a transition. So we have a strong embedded base today, whether it be fixed function devices and sensors that are sitting out there, on an oil tanker or in an agricultural environment, to other devices that may be autonomous vehicles and so forth. But that's the AI of today. And there's going to be a lot of transition here over the next 5 to 10 years in the type of compute, utilization of memory, driving power down, and so forth. It's dramatically going to change as part of that. As I mentioned earlier, and you commented on, education. One thing I can say is, as one of the startups here, we're a fast growing company, and going out into the field and try to bring good people on, programmers, engineers, developers. We're gonna we see a growth and a need in education as well. So it's encouraging to hear that this is being built into universities, for example. And I'll add just one funny story here, just to show how AI is not just for the technical people that are at this conference, and for us to know. In the example I gave on X-ray, in our interviewing and engaging with various different medical professionals in different geographies, we had one medical doctor, actually an X-ray doctor, he started asking us how many layers were in our network. Were we doing floating point 32, 16? Were we down to 8? How fast were we inferencing? And it just totally blew me away, because it's this medical doctor, highly trained in how to visually look at X-rays, had started spending the time to truly understand how AI is going to change his industry and field. Right. And that ties back into, yes, AI is out there in embedded devices. It's going to transition, it's going to change, it needs to. And I'm super excited about it, because it's a fast growing industry for sure. So
I think just to sum up, even throughout the discussions, now we're talking, I think the biggest question used to be, was it cloud versus edge? Now we're talking about edge versus mini edge, micro edge. We're talking before it used to be ML, now it's tiny ML. So to what extent are we trying to bring down? Again, it goes back to the 3 P's: price versus power versus performance, and where each of these applications are required. And that's the key thing, I think. If industries are being pushed to adapt to this, what levels of communication is happening, and how are we taking this up, is a crucial role. I think that sums it up, but I wanted to thank each and every one of you for participating. I hope even to the audience, this was enlightening from our speakers, how it we were able to answer some of the questions. And before we sign off, I actually just wanted to congratulate both Sean and Malik for making the top 100 AI companies by CV Insights for AI processors.
Thanks.
great. Thank you.
Congratulations.
Thank you very much. Thanks for your time, guys.
Thank you. I'll
Appreciate it. Thank you.
Thank you, guys. Thank you very much.
Bye-bye.
Bye-bye.
Thanks, Gangadhar, for the deep insights on engineering AI in future, of any applications. Thanks a lot.